Okay, so you're asking the difference between x squared and 2 to the x, and sort of just by reversing those two things, what happens? So for me, I'm like super visual learner, so I would, to figure it out, I would plug in points and then just actually see what happens. So let's see what happens. If we plug into, oops, didn't mean to do that one. If I plug into x squared, you've seen this table by a bazillion times, but negative 2 times negative 2 would make a 4. Negative 1 times negative 1 would make 1. 0 squared is 0, 1 squared is 1, and 2 squared makes 4. And so you can see we're going to get what's called even symmetry, and it's called that because when we have an even power, what we get is for opposite x's, we get out the same y's. And we get a graph over here, there we go, that has that symmetry about the y-axis, where if I took this and I folded this piece of paper across, it would sit right on top of itself if I folded it across the y-axis. And I'm waving my hand here in the air like you can see that. It was kind of funny. But anyhow, so this says even symmetry, and you can see it's going to do this forever, right? If I put in negative 3, it's going to be a positive 9. It's going to be bigger than it was. It's going to keep getting larger by larger increments every time. And then the same thing on the positive side, positive 9, positive 16. So if I do x, or 2 to the x, what happens over here? If I go 2 to the negative 2, I'm just going to slip that in the middle here. That would be the same thing as 1 over 2 squared. Because remember, when we have a negative exponent, we can bring that down to the denominator, or 1/4. And so likewise, if I did negative 3, that would come out 1/8. Negative 4, 1/16. And so that pattern would continue forever. 2 to the negative 1 would be 1/2. And then 2 to the 0, anything to the 0 makes 1. And then 2 to the 1 is itself, it's 2, and then 2 squared makes 4. So you can kind of see what this pattern looks like. This is going to go, so it starts off at anything to the 0 is 1, and then 2 squared is 1. Sorry, 2 to the first is 2, 2 to the second is 4. If I did 2 cubed, we would get 8. And the fourth, now we're up to a 16. And so this thing is going to start growing really fast, is kind of what happens in 64 and 128 from there. When we're at a 5 over here, we're only at 25. So this thing already overtakes it by the time it gets to x equals 5. The other thing to notice about this is I can never make it get to 0. If I do negative 3, it'll be an 1/8. Negative 4, it'll be a 16th. It's going to, what's called asymptotically approach 0, get closer and closer, but never actually touch, because you're always dividing by 1 over a larger number. So graphically over here, that one looks like that, blue. Let me get rid of the red one so you can see the blue one better. But so there's our 0, 1. When it's 1, we get 2, somewhere around there, and then 4 and 8, and so forth. And on this side, you can see, let me zoom back, it's just going to get closer and closer and closer and closer until it's not really 0, but this is only going to 3 decimal places. So already by like negative 11, it's 1/10,000th or something crazy small. So exponentials get crazy small when they go this way and crazy large on the other side. And x squareds, or even functions, they have that symmetry about the y-axis, and it's literally just when you plug in the points, it's what they do. So for me, this is kind of how I get a sense as to what they do, is I like physically graph them on paper and looked at it and went, okay, well that makes sense, I guess that's what they do. Hopefully that made some sense for you. Let me know if you have a follow-up question.